Today we're going to talk about arithmetic sequences. So first off, what is a sequence? A sequence is an ordered list of numbers. So that's just any sequence. We know we've seen all kinds of sequences. It's a list of numbers, 1, 2, 3, 4, 5. That's a list of numbers in order. -2, 0, 2, 4, 6. That's an ordered list of numbers. An arithmetic sequence is a special type of sequence, and this sequence has a constant difference between consecutive terms. Consecutive just means one after the other. This constant difference is also called the common difference. So those mean the same thing. So, down here we are going to tell whether the sequence is arithmetic. If it is, tell what the common difference is and find the next two terms. So we're looking at number 1 here. So they're in order, so it's definitely a sequence. When I go from -4 to 1, I'm adding 5. When I go from 1 to 6, I'm also adding 5. From 6 to 11, I'm adding 5. And from 11 to 6, I'm adding 5. Because I'm adding the same exact number every time, this is arithmetic. Its common difference is 5. To find the next two terms, I'm just going to add 5 on. So 16 plus 5 is 21, and 21 plus 5 is 26. So on number 2, when I check this, from 3 to 5, I'm looking for an adding and subtracting pattern. On this one, I'm adding 2. 5 to 9, I'm adding 4. 9 to 5, I'm adding 6. And from 15 to 23, I'm adding 8. Now I have a pretty cool pattern there, but it is not arithmetic. I'm not adding the same number every time. So this one is not. This one was, yes, it was. So there is no common difference. We could find the next two terms if we really wanted to, because we can see the pattern is 2, 4, 6, 8. So the next term would be 10. So if I wanted to, I could find the next term is 33. And the next term I'd add 12 and get 45. But this is not arithmetic. Go ahead, let's try number 3. On this one, notice we're taking away 3. Well, subtraction is the same thing as addition, it's just adding the opposite. So instead of saying -3, I'm going to say I'm adding -3. From 32 to 29, I'm adding -3. From 29 to 26, I'm adding -3. So because I'm adding the same number every time, this is arithmetic. The common difference would be -3. So my next term would be 26 plus -3, which is 23, and then 23 plus -3, which is 20. So I want you to take a moment right now and figure out first if 4 and 5 are arithmetic or not, right? Yes or no. If it is, put the common difference and then the next two terms. When you're ready to check your answers, turn the video back on. Alright, if you're ready to check your answers, number 4 is an arithmetic sequence. You are adding -30 every time, which means the next two terms are -154 and -184. Number 5 is not, because you're not adding the same number. Actually, what you're doing is multiplying the same number every time, but that's not arithmetic. You have to add. This is actually another special type of sequence which we will call geometric, but you won't get to that till chapter 8. Alright, now it's your turn. I want you to take a minute, and I want you to come up with at least 3, 1, 2, 3, sequences that you would think are arithmetic. They have to have at least 4 terms. Then I want you to come up with 3 sequences that are not arithmetic. Once again, they all need to have 4 terms. So take a minute now, come up with your arithmetic and non-arithmetic sequences. Alright, hopefully by now you've been able to come up with a couple of sequences to share. I came up with 2 each. Remember, yours do not have to look like mine. Okay, as long as your arithmetic sequences are having the same number added. So like here I'm adding 1 every time. On this one I'm subtracting 10 every time. We're adding negative 10. This is not arithmetic because really there's no sequence. I'm adding 6, then I'm adding 2, and then I'm adding 12. Not really any pattern there, but it's still a sequence, it's just not arithmetic. This one here I'm adding 2, and then 4, and then 6, so it's a really cool pattern, but still not arithmetic. So make sure you have that filled out. Next thing we're going to do is actually graph a sequence. So when you're graphing a sequence, the first step is to number the terms in the arithmetic sequence. So to number it means same numbers you count. So for example on number 1 here, I'm counting these terms. Negative 4 is a term, 1's a term, 6 is a term, etc. So number 4, negative 4, is number 1. That's my first term. 1 is my second term. 6 is my third term. 11 is my fourth. And 16 is my fifth term. I have 5 terms. I numbered them. 1, 2, 3, 4, 5. That's what step 1 means. Step 2 says create a table. Let X be the term number, which is the number we just wrote, and Y be the actual term. So we're going to make our table. I'm going to make this a horizontal table. So X and Y. I have 5 terms. The X is the number we put on top. That's why I put it on top. The Y is the term. Negative 4, 1, 6, 11, 16. Then step 3 is to plot the points on a coordinate plane. Okay? So that's what we're going to do. Notice I don't really have any axes here. So I'm going to draw them in. I'm going to put the Y one somewhat in the middle. And I'm going to put the x-axis a little down low because I have some really big numbers for Y. I'm going to try to fit them on here. Not sure if we'll be able to, but we'll see. So 1, negative 4, 1, negative 4, 2, 1, 3, 1, 2, 3, 4, 5, 6, 4, 11, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Out right there. And 5, 16 is really far off our graph. So 11, 12, 13, 14, 15, and somewhere up there where my 16 is. Can't really fit it. So this is what the graph would look like. Now it is actually discrete here. We're not going to draw a line because we are not really allowed to use any numbers in between. However, it does continue on forever. So the graph is discrete. It's kind of understandable to put a line through it to show that it continues forever, but we're not going to. We're just going to graph the points we can get on it. So number 2, 0, 2, 4, 6, 8. First thing we're going to do is make a table. X and Y. Remember, our X is always our term number. So we have 1, 2, 3, 4, 5. So that's what I'm going to write for X. 1, 2, 3, 4, 5. You're never going to have negatives here because you don't start with a negative 1 when you count. You count with 1. 0, 2, 4, 6, 8 is the term. I'm going to draw my axes in. So 1, 0, it's right there. 2, 2, 3, 4, 4, 6, and 5. Oops, I went over a little too much there. 5, 8. So there's my graph. Go ahead and take a second right now and try number 3. Number 3 is going to be the points, the sequence, the sequence. -3, -4, -5, -6, -7. So take a minute, graph that sequence. Alright, hopefully you're ready to check your answer. So you should have set up a table that looks like that, and your graph should look like that. Okay, make sure you didn't draw a line, because yes, the sequence does continue on forever, but it is actually a discrete graph. Now, what do you notice about the points we plotted in the above graphs? Hopefully, you realize that they're very linear. That's probably why you've been wanting to draw a line. So, they are linear, which means we can actually write them as an equation. That's what this whole chapter has been about. So, we are going to actually write a rule. Remember, a rule just means write an equation for the nth term of a sequence. When they say nth term, that just means the unknown term. Maybe I want to find the 100th term, maybe the 5th term, maybe the 1,000,000th term. So to find the nth term of a sequence, you can write the rule in the form of a sub n equals a sub 1 plus m minus 1 times d. Now, the good news is I'm not going to make you memorize that formula, but you do need to know what they mean. So, a sub 1 is the first term, which makes sense. It has a little 1, first term. The d is the common difference. This n is the number of the term. These two n's go together. It's kind of like that's x and that's y. So in number 1, it says write a rule for the nth term of the given sequence. So the first thing we have to know, well, the first thing we're going to write is a sub n, because that's like our y. The first thing we have to know is a sub 1. A sub 1 is the first term. So that's going to be -4. Plus, we're going to leave n minus 1 in parentheses because we don't know what the nth term is yet. That's like our x. The common difference, we're looking to see what I'm adding. Add, let's see, -4 to 1 is add 5, add 5, add 5, add 5. So the common difference is 5. Okay, you don't have to put the 5 in parentheses. However, I do encourage it because if there's a negative there, you have to have the parentheses. So that's our rule. Then it says find a sub 17. That means find the 17th term. So where that n is where we're going to put the 17. So -4 plus n is 17 minus 1 times 5. Then honestly, we can just use our calculator to crunch those numbers. You can do it in your head if you'd like, but why not use our tools? So -4 plus 17 minus 1 times 5. So the 17th term is 76. So a sub 17 equals 76. And that would be our answer. Alright, let's try number 2. 4, -3, -10, -17, and so on. So we're writing our rule. The first thing we write down is a sub n. That's like our y. Then a sub 1 is our first term. So since 4 is the first term, I'm going to write 4 plus n minus 1 stays right there in parentheses. It Now we need to find the common difference. Notice in this problem we are adding a negative 7 or subtracting 7 every time. That means the common difference is negative 7. You cannot write it like that. That means minus 7. We're not subtracting 7. We're multiplying by negative 7. You have to put the parentheses, otherwise it is incorrect. This is our rule. So now we want to find the 100th term. So we're going to put 4 plus 100 minus 1 times negative 7. Once again, using our calculator, 4 plus, don't forget the plus, 100 minus 1 times negative 7. That gives me negative 689. So the 100th term, I'll just write it down here, is negative 689. Please don't forget the plus sign. Okay, this is here. If you do, it'll be incorrect. Because notice, if you don't put the plus, it's a completely different number. Much larger number because you're multiplying. Alright, let me give you the problem for number 3. It's negative 1, negative 7, negative 13, negative 19. I want you to find the rule and then find the 34th term. Alright, hopefully you're ready to check. So the rule is a sub n, make sure it says a sub n, equals, negative 1 is the first term, n minus 1 in parentheses, don't forget the plus, that plus is very, 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 very important. And then parentheses around negative 6. You are subtracting 6 every time, which means that's the common difference. If you do not have parentheses, it is incorrect. Make sure you also have the letter n. The 34th term, when you plug it in, is negative 199. Now that you've finished your notes, make sure you put this in the notes section of your notebook, and you want to work on your homework.